Welcome back to another video. Would you believe me if I told you that I went to yoga? No, it's a bit of a stretch. Okay. We're looking at new topic. We are talking about the coordinate plane. Now, hopefully I've done this correctly. Yes, we are talking about the coordinate plane. Essentially, we're going to be doing two types of questions. You're either finding a length, midpoint, gradient on using 2 points on a Cartesian plane, or we're going to find equations of straight lines on a Cartesian plane. Both very important. And then, of course, there's the applications. Now, distance, midpoint, and gradient. These three things you will have to know. Your formulas will not be given in the reference sheet. You will have to memorize these, okay? Let's talk about each one. Just some general notation here. If I say x1, y1, that means it's the x and the y coordinate of point 1. That's the x and the y coordinate of point 2, x coordinate and y coordinate of point 3, etc., etc. That's just a little bit of notation. Okay. Now with distance formula, I hope it makes sense that you're finding a length between 2 points, and your distance formula is given by this guy here. So it's very, very similar to Pythagoras theorem. So you'll notice that there's some squares in a square root. But in this case here, it's going to be y2 minus y1 in brackets squared plus x2 minus x1 in brackets squared, and then that whole thing square rooted. That gives you the distance. Your midpoint formula, it makes sense. It gives you the middle point. Now I'm going to point this out. I'm going to point this out that if it's a midpoint, it makes sense that I'm not getting a singular value. I'm actually getting two. If it's a point, there's always an x coordinate and there's always a y coordinate. Now it makes a little bit of sense that halfway between x1 and x2, so x1 plus x2, and you divide it by 2, that gives you your midpoint of your x's, and your y1 and y2 over 2, that gives you your midpoint of your y. That's given by capital M, okay? Not to be confused with the next one, which is gradient. Okay, now the gradient formula, I'll leave that for now. The gradient is going to be, essentially, it gives you the slope. If it's really steep or not very steep, you'll get your gradient. They let it equal the letter M. You should be familiar with this, but if not, little m. Okay, now there's three formulas that you can remember. It's either rise over run, or the coordinate version would be y2 minus y1 on x2 minus x1. You'll notice it's kind of like the same order as distance, just this time there's no squares. And the other one, which a lot of people forget about, is this guy down here, tan theta. So just don't forget that that is a valuable method to find the gradient, okay? And I'll show you what I mean by that. So when we're talking about gradient, the hardest part to understand is probably what each of these things kind of represent. So with this one here, can you see how, let's say, for example, if it's 1, 1, or, 2, 2, blah, blah, blah. If it's a 1-to-1 gradient, which is our kind of standard, this is what we call our gradient, or let's just label our gradients here. That's a gradient of 1. Okay, if I was to write all these out, this would be a great, my equation would be y equals to x, but my gradient is theoretically 1. For this one here, this is actually a gradient of 2 because it's steeper. So that means we're steeper. This one here would be actually a gradient of a half, 1 over 2. And then we can kind of keep going this way. This would actually be m equals minus a half because it's now negative. We're pointing to the bottom right. This one here, this light blue line will actually be m equals to -1. And you'll note here that it's actually 90 degrees with the, it's 90 degrees with the m equals 1. So it's kind of like they're the opposites of each other. And then you'll also have this one here, -2. And of course, if I go steeper, hopefully you get an idea. That's going to be your visual representation of what the gradient is and how steep it is. Okay, let's try do some questions here. We've got 2 points. We've got A and we've got B. You want to find the gradient, midpoint, and the distance. The easiest way to do this is honestly to label your points. Okay, I find most people will make mistakes because they don't label their points, or they'll label their points incorrectly. Remember, every point has one x value and one y value. Okay, not x1, x2. It's every point has one x and one y coordinates. So if we're finding the gradient, let's go in this order. It's going to be y2 minus y1 on x2 minus x1. In this case, it's going to be -1 minus 3 over -4 minus -1. Be careful with your brackets and everything. This will give you -4 on -3. And that should just be +4 on 3. That's correct. Okay. And if you really want to, some people will be a little bit pedantic about their setting out. That just means it's the gradient of the interval AB. Okay, so that's gradient. Let's find the midpoint. And again, we know the midpoint is given by x1 plus x2 on 2, and it's a point. So that means I also have a y bit, or y1 plus y2 all on 2. So for this one here, it's going to be -1 plus -4 on 2. And then it's going to be y1 plus y2, which is going to be 3 plus -1 on 2. Note how I'm using all these brackets just to make sure I don't mess up any of my positives and negatives. -1 plus 4, or -1 minus 4, should I say, is -5 on 2. And then for 3 plus -1, it'll be, yes, 2 on 2, which will be just 1. So that there is your midpoint of these 2 points, midpoint of A and B. Okay, and the last one, your distance, is just going to be the square root of y2 minus y1. Now note it's not squared, like it's y subscript 2. Just thought I should make that a little note. It should be, it is minus x2 minus x1 all squared. And so again, let's take a look. Y2 is going to be -1, -1 minus 3 squared plus x2 minus 4 minus -1 squared. And it's all going to be under a square root. This is going to be -4 squared plus, what is -4 plus 1 minus 3 squared? And I should have put those in brackets. And so this would actually give me, wow, 16 plus 9. And who knew it'll be such a nice value, 25. It'll just be the distance of A and B is just going to be a distance of 5. All right, there you go. Hope that helps. Is that it? Last one. Okay, don't forget this. Gradient of the line that makes an angle of 60 degrees with the x-axis. So they're talking about a gradient, and they've also given you an angle. So we know that the gradient is also the same thing as tan theta. In this case, your gradient is going to be whatever tan 60 is, because that's the angle that it makes. And so if I look at I recognize this is a exact value triangle. If not, you can use your calculator. But because I recognize that that's 60, we can see here that my gradient in this case is √3, because it's opposite over adjacent of my 60-degree angle. All right, cool. Hopefully that makes sense. All the best and good luck. All right, bye.